Welcome to the debrief for the FITTS Law Lab 8. The first thing that I want to start off with is the two equations that are located in your lab manual. The first being that the movement time is the time per tap in seconds, and so that can be calculated by taking 20 seconds and dividing it by the total number of taps. So the total of number of taps would be both hits and misses. This equation is usually pretty simple and students understand this very well. Where we've had students who've had difficulty in the past, pun not intended, is with the index of difficulty equation. And so I just want to take a couple of minutes to explain that to you. So here we have the index of difficulty is going to be equal to log to the base 2, and then brackets, 2a or amplitude divided by width. So what this means here is that difficulty is going to increase as amplitude increases, and difficulty is going to decrease as width increases. So I think intuitively most people understand that. Where they get tripped up is how to actually plug in a log on their calculator. So I would strongly advise you that you practice this ahead of time. Make sure that you're practicing it before you write any of the exams for this class, because each calculator is different. So I'm going to explain it in general terms, but you have to practice it on the calculator that you are going to be using for any exam. So it has to be a university approved calculator, and you're going to want to practice it on there. So as an example here at the bottom, I've highlighted in purple the first condition, and I just want to elaborate more on that equation. So if we have an amplitude that's equal to 2 inches and a width that's equal to 0.5 inches, what that's actually going to look like is ID is equal to the log of base 2, open your bracket, 2 times amplitude divided by width. So that, and then close bracket. So that's going to be equal to the log of base 2, open bracket, 2 times 2 inches divided by 0.05 inches, which is then going to be equal to the log of base 2, and the answer in this case is going to be 8. And so when you plug that into your calculator, you are going to get an answer of 3. And so the index of difficulty would be 3 bits in that equation. And so on an actual calculator, the way that you plug that in is going to be log 8 divided by log 2, which is going to give you an answer of 3. Or you might have to press in 8 log divided by 2 log, and that's going to give you an answer of 3. And basically all that means is that 2 to the exponent 3 is going to be equal to 8, or 2 times 2 times 2 is equal to 8. To further elaborate on this concept, we've included a quick tutorial on logarithms, and that can be located in Appendix A in your lab manual. And just to refresh, because it's probably been a while since you've looked at logarithms, a logarithm of a number is just the exponent by which a fixed number, that we refer to as the base, has to be raised to produce that number. So the example that you're given here is log of 1,000 to base 10 is 3. And the reason why that is because 1,000 is equal to 10 to the power of 3, or 10 times 10 times 10 is 1,000. Another way that this could be stated is that 3 is the logarithm of 1,000 to base 10. And if we had a second example, for example, if we had 8 is equal to 2 to the exponent 3, that would be referred to as 3 is the logarithm of 8 to the base 2. So I don't want to get too far ahead of myself there, but I'm going to explain the difference between if you have a logarithm with a base 10 or if you have a logarithm with a different base. So before I further elaborate on the differences in base 10 or a different base with that last example that I just gave you, let's return to the first example. So if we have a log to the base 10 and your answer is 1,000, the exponent would be 3. I previously mentioned that you would literally be typing in to your calculator. For example, on an iPhone, you'd be typing in 1000 and then you would be hitting the button that's log to the base 10, and that is going to give you an answer of 3 because 10 times 10 times 10 is 1000. The second example there is if we have log to the base 2 with an answer of 8, the exponent is going to be 3. And so 3 is the exponent to which the base 2 must be raised in order to create the answer of 8. Another way of saying that is 2 to the exponent 3 is equal to 8 because 2 times 2 times 2 is 8. Now, the way that you would actually type that into your calculator, for some of you, you'll have to practice on your own calculator, is log 8 divided by log 2 is going to give you an answer of 3. On an iPhone, and I'm just telling you this because you might attempt to practice on an iPhone, however, you know that you are not allowed to use an iPhone or any phones whatsoever in an exam for this course, but just for simplicity, because you probably have your phone right beside you, so that you can work through it, you would be typing in 8 log divided by 2 log, and that will give you 3. And so 3, once again, is the logarithm of 8 to base 2, or 2 needs to be raised to the exponent 3 in order to equal 8, or 2 times 2 times 2 is equal to 8. I want to present all of the different ways that you could look at this in the hopes of helping someone who's really struggling with this. If you already understand logarithms, then it isn't a problem, and however you like to think about it in your head is totally fine, and disregard the different ways that I'm explaining it. So just one more time, because we know that students struggle with this concept. Here at the bottom of this slide, I have log 2. So in this case, the base is 2. The answer is 8, and the exponent is 3. So something to remember when you're looking at logarithms on a calculator is that the log button on a calculator is going to assume a base of 10. So that's why we had the example where the log of 1000 is going to be equal to 3 because 10 times 10 times 10 is 1000. We also have a second example here, log of 100 is equal to 2 because 10 times 10 is equal to 100. So that is if you have a base of 10. For bases other than 10, and that brings us to the equation that we started at today. So if you have a base of 2, then what you would have to do on your calculator is actually type in log of your answer divided by log 2 in order to determine your answer. So for example, log to the base 2, when your answer is 64, you're going to physically type it into your calculator as log 64 divided by log 2, or some calculators might be 64 log divided by 2 log. The answer to that is going to be 6. And the reason for that, or I should say the exponent is going to be 6 in this case, because the answer obviously is 64. The reason for that is because 2 times 2 times 2 times 2 times 2 times 2, it's a bit of a tongue twister, but I said 2 6 times there, is going to be equal to 64. Or 2 to the exponent 6 is going to be equal to 64. So at the bottom here, we've provided you with many different examples. Basically, keep in mind the log of your answer to the base number that you're looking at, in this case we're going to be looking at 2, is the exponent number. So if we look log to the base of 2 and your answer is 2, physically type it into your calculator as log 2 divided by log 2, you're going to get 1. If you have log to the base of 2 with an answer of 4, physically type it into your calculator, log 4 divided by log 2, and that's going to give you 2, meaning 2 times 2 is equal to your answer of 4. On the next line, 2 times 2 times 2 is equal to your answer of 8. On the next line, 2 to the exponent 4, or 2 times 2 times 2 times 2, is going to give you your answer of 16, and so on and so forth. So hopefully that clarifies logarithms in a nutshell, and then you can then return back to that original equation that we started at, which is the index of difficulty is going to be equal to log to the base 2, open your brackets, 2 times the amplitude divided by the width, close your brackets. keeping in mind that difficulty is going to increase as amplitude increases and difficulty is going to decrease as width increases.